Okay, I don't have anything finished to show you today. It's just work in progress. I've got this 3D printer here printing harmonica combs. The finished comb looks something like this. I've got a comb and a mouthpiece, and it's all one piece printed up from the bottom. It goes up to the mouthpiece at 45-degree angles. The mouthpiece will have 2 rows of holes, so you can blow in to one reed plate or the other by tilting the harmonica. The base harmonica that I'm working from is a Chromonica 260. It's got a slider, but I'm not going to use a slider. I'm going to instead rely on tilting the harmonica one way or the other to choose whether you do this is the bottom row of holes, this is the top row of holes with the slider in, slider out, instead of tilt the harmonica. The advantage of doing it this way, well, one advantage is that these things are from 1938 and the pearwood combs are soaked with smoke, and you can't fix that, and they're usually broken too. And lots of air leaks through the slider itself and between the slider and the comb. With this, there is no slider, there is no gap between the mouthpiece and the comb, so no air can leak there. Air can still leak out between the reed plates. Here's a reed plate from one of these Chromonicas. And it goes on, let's see, there's a ridge here that tells me what the outside is. So that's the outside, so like that. It goes on like that. So you could still have air leaking between the reed plate and the comb, but you can't have it between the mouth and the comb anymore. So the way to reduce the leaking between the reed plate and the comb is you use valves. Let's see where my favorite valve here. So I cut some valves out of paper by hand, and it should fit like that. But you see, this is really hokey and very time consuming, and I have to be sub-millimeter accurate, and I'm just not by hand. So I got a machine to cut things out by CAD/CAM design, and there it's doing better. I actually need 2 varieties. Which reed is blocked varies on whether it's the top or the bottom reed plate. So I've got 2 templates, and one goes on one side and one goes on the other side, and then the reed plate goes over like so. And then the paper sort of fills in the gaps between the rough comb and the reed plate, and also covers the draw reeds so you can bend blows. That's the goal here. But I don't have the pattern right yet. The screw holes are off a little bit, so I end up blocking draws entirely. I gotta adjust my designs. This design isn't finished yet either. Let's see. Here's an earlier version. You see here the mouthpiece doesn't stick up much. Here the mouthpiece sticks up much more. I decided this was too bulbous and didn't like it. I tried having gaps for the heads of the reeds, and that turned out to be a disaster. the 3D printing made lots of bumps trying to make these indentations and made things much less airtight, so forget that. These square holes are probably not the final design either. We have reeds on opposite sides that go like this or like this or like this. So it makes sense to have the bottoms like this or this. So the bottoms like this for the reeds that go like this, and the bottoms like this for the reeds that go like this. And that would take the place of these completely rectangular holes. But I'm not at the point yet where I can test that yet. It's still not airtight enough to do anything with. I gotta get the valves right before I can do that. So that's sort of where we are. I've learned 3D printing in the process. I made these little cubes with spheres removed to show that I knew how to do the CAD CAM and to test what the printer could do. And then I exercised my CAD CAM skills a bit more and made a dense packing of spheres and removed that from a block and printed this. And I tried printing it with, I think this one's with ABS, which is a harder, more robust plastic. And I tried making a comb out of ABS, but if you look at the bottom here, it's way, way bent. This has to be accurate to within sub-millimeter, and this is off by 2 millimeters. This is completely unusable. This one is also ABS, and I succeeded in getting it to stick to the plate by using a brim around it. Unfortunately, it stuck too well, and I couldn't get it off. I ended up breaking the other side of this base, pulling this off. So I've still got to learn how to use ABS without breaking my machinery. So, you see, lots of things in progress. Eventually we'll have a harmonica that is airtight and half valve, so you can bend both blow bends. You can do both blow bends and draw bends, and it'll reuse the reed plates and the face plates from these Chromonicas. But I'm not there yet. It'll look something like this, but this one doesn't. Oh, I 3D printed some little spacers too, but this one doesn't have any valves yet. I probably have to make the comb thinner to make space for the valve, what the valves take up, but not there yet. I tried 3D printing a template for making the valves, but then cutting it by hand, it turns out no, it's still too labor intensive and still way too inaccurate if I do it by hand. Doing it by machine is much better. Well, that's where I am. Eventually I'll have something finished, but right now it's just learning the tools.